So horizontal motion of the piston rod of the hydraulic cylinder controls the rotation of link OB about O. For the instant represented, VA, so the absolute velocity of point A, is equal to 2 meters per second, and the link OB is horizontal. So we're asked to determine the velocity of the link OB for this instant. So this is going to be a question where we need to consider the relative velocity of the different components. And because we're given, I guess, the velocity of A, and we're asked to find the angular velocity of this one here, this link here, which is going to be related to point B. The ones that we're going to want to consider it between are A and B. So we can say that the velocity of point A relative to point B is going to be equal to VA, which we are given, minus VB, which we should be able to solve by looking at the rotation of this link. So I'm going to go through and find each of these individually, and then we'll fill in the equation. So let's start with the velocity of A relative to B. We know it's going to be equal to the angular velocity of that link that joins them, alright, multiplied by the relative radius between these points. So before we go any further, we probably want to draw a coordinate system so that we can measure things based on it. And I think the regular coordinate system is probably the best one. So we have x, y, and the z axis is out of the page. So let's take a stab at what the angular velocity of AB is. I like to just assume that it's going in the positive direction, which is anti-clockwise when you define z as out of the page. So that's what's going to go into this equation here. And it gets a k when we put it in vector form because it's rotating about the z-axis. So now we just need to multiply it by the radius of A measured from B. And unfortunately, I don't think we're given enough information to just quickly get this off the diagram. We have to end up getting a triangle out. So if we look at the triangle that sits in here, okay, so we know it's got 180 millimeters on this hypotenuse. This vertical length in here is 160. And we need to measure what's happening from B down here to A up here. So joining the arrows, it would look like this. So basically we just need the length of this line. We know it's a right-angled triangle. So if you use Pythagoras theorem, it will be the square root of 180 squared take 160 squared. So this ends up working out to be 82.46 in millimeters for the length. So coming back down here and using that, going from B back to A, so on the vertical part it's going to be positive 160j because we're going up on the y-axis, and then it's going to be in the negative x direction, so negative 82.46i. So now we just need to simplify this out. So it's going to be 160 times omega. And remember your diagram to help you out with positives and negatives when you're multiplying unit vectors. In the direction of the arrow is positive, in the opposite direction is negative. So k times a j is in the direction of the arrow, in the opposite direction of the arrow, so it's going to be a negative, and it's an I. So then we have omega times 82. Okay, and k times I is going to be a positive value, so the sign stays the same, and we get a j on the end. So there's not much more we can do with that one. So now we move on to the velocity of A, which was the next term in our equation. And fortunately we've been given this, alright? We know it's 2 meters per second, so all we need to do is convert this into a vector form. And since it's basically running along the x-axis, we can just write this as positive 2i. Alright, so one left, and that's the velocity of B. So we know point B here is connected back to O, and we can use that to our advantage. So it's going to be equal to the angular velocity of that link, which I'll call OB, multiplied by the radius, and it needs to be measured back to the fixed point, so B relative to O. Okay, so recall that the reason that we do this is, if I just make a little side note, if you look at the velocity of B relative to O, it would equal the angular velocity at which that link rotates, multiplied by the relative radius. And again, the notation here needs to reflect the notation in here. The other thing that we can consider is that the velocity of B relative to O is going to be equal to the difference in their absolute ones. But because point O is fixed, it's not going to have a velocity. So basically, if we substitute this back up into the first equation, we end up with the velocity of B is equal to OB times RB slash O. Okay, so if you just remember that you need to measure these ones relative to the fixed point, it's basically going to do this step in here for you. Alright, so let's fill this in. So the angular velocity of B relative to O is unknown, so again we're going to need to take a stab at what that is, and I'm just going to assume that it's going to be in the positive direction. If it comes out negative, then we know it's the other way. So scrolling back down, I'm going to say omega OBK in vector form, multiplied by the relative radius, so it's B measured from O, so this is going to be in the negative x direction, so negative 120i, and if we simplify this down, it's going to become negative 120 omega OB, and k times I is a positive value, so the sign doesn't change and it just gets a j. So now all we need to do is go back and put our three different terms we worked out into this equation. So filling that in, so this is going to get a double negative when we sub it in, like that. So we need to solve for our two unknowns, and we have the ability to split this equation into two, one for the i's and one for the j's. So this time I'm going to start with looking at the i's because we only have one unknown tied up in that. So we're going to get negative 160 omega AB is equal to 2. Oh, and I've just realized I made a small mistake. All of these different dimensions I measured in millimeters, okay, but this was in meters per second. So all I've got to do is just either convert everything from millimeters to meters or meters to millimeters. So I think the easiest one is just to fix this one up. So this should be 2000 I, because it's 2000 millimeters per second then, which reflects all these other units. Sorry about that. So this just becomes 2000 in here. Alright, so that's going to fix it up and we'll get nice units out at the end. So this is going to be millimeters divided by millimeters. So we just end up with radians per second, and it's in fact negative 12.5. And for the J, taking those ones out, we get that for our equation, and we're interested in omega OB. So rearranging and subbing in, we get an answer of 8.59 radians per second. So all that we need to do is assess the directions that these are going to be in. So we assume both of them were the positive direction, which is anti-clockwise. So this one came out positive, so that means it was true. This one came out negative, so it's going to be clockwise. So that's all there is for that one. See you in the next video.